All right, so let's get into the problems that we faced during this process. So let's first go into the housing of all the parts. So we were initially trying to use Legos, but they have like their own proprietary measurement system, which really doesn't fit with anything that we're using here.
Especially the ultrasonic sensors.
Exactly. So like,
you want to go?
it wasn't like cohesive. Basically, it just didn't really work.
So
out.
we basically decided to use cardboard because it was much easier to change than plastic.
Yeah.
And it also helped with the positioning of the ultrasonic sensors, as we could make it exactly parallel.
Yeah.
And obviously create a hole for the water.
We were trying to make the Legos, and what we first wanted to do is kind of make something that went around the entire tank, and like it was hard to secure it in place, and like I don't know, it wouldn't have been exactly parallel like Umesh said, and there would have been more problems. So yeah, we decided to go.
It took us a whole week to realize that we could just use cardboard. That's like the worst part of this. But one thing I would like to add is that there's one thing that we faced with using cardboard is that with us using water as like with us using a liquid, it kind of drenched the cardboard sometimes, and this caused like problems with the placement of the sensors.
Yeah, especially because like there's a hole in the middle of the cardboard housing to let the water flow through from the tap, like Umesh was saying, and sometimes if that wasn't positioned exactly correctly, the water would like get onto the cardboard, and that would just like spread because the cardboard would like absorb the water.
Yeah, and the tap was like pouring out the water in like unpredictable directions.
Yeah. Okay, now let's get into the other problem of the motor's power. So originally when we were using the Arduino motor, or just like a separate motor, it didn't have enough power to push the lever down. So then we decided to replace it with the EV3 motor, the Lego motor, which was the most powerful one we had. Yeah. But that soon had problems as well.
So with the Lego motor, first of all, is like the wire, it has its own proprietary connector, right? So what we did was that we had to do some research about the pinouts of the wire, and we found out which one was the power and which one was the ground pin. Yeah. And using that, we were able to solder it. Okay. Yeah. So we soldered a new wire that we could use for this EV3 motor to use it with our Arduino.
Yeah.
And the lever that we were using, it was already made of Legos when we started, because that worked with our Arduino motor, in fact. But it actually worked even better when we started using the Lego motor, because it has its own like Lego, I guess like the pin, I don't know what you would call it.
It's called an axle.
Yeah, the axle that goes through the middle of that Lego motor is a lot better to use with the lever that we were using.
Before moving on, one problem that we did face with the motor was the weight.
So when testing the weight, we had like many creative approaches, and we would add like some of these random pieces. I think you guys even used the rocket one.
We did.
But so then we soon found out, after placing the wheels in different positions, some random Lego blocks, we found out this was putting the two wheels at the edges had enough weight to push down properly.
Yeah. So when we were talking about the weight, it's basically that the motor didn't have enough weight on it to push the tap down when it rotated this way, like rotated downwards. So adding the wheels on the side is what actually allowed it to push down.
Exactly.
Also, going back to the soldering with the wires that we did, make sure to keep everything organized, because I think the first time when soldering, we sort of messed it up a little.
Yeah. So when you're working with this particular type of wire, you have to make sure that you keep all the copper, the individual copper wires separate to each other. And the way we did that was that we did each wire separately, and then we taped it, and then we did the same thing for each color of the wire.
Yeah, because sometimes if they cross over, there's also a danger of creating a short circuit, which we don't want to do. Yeah, another problem that we also faced was attaching the motor to the actual tank. So we first started, we were trying to like use some, I don't know, like hot glue or something to get it to stick, but it wouldn't really stick that well.
Yeah.
And especially when it pushes the tap down, it started to like detach itself from the tank. So we finally found this like really strong double-sided foam tape, and it's actually the same tape that's on the back of the breadboard and the Arduino.
Yeah.
And it keeps everything attached really like firmly against the tank, and it wouldn't move.
The tank itself is like really smooth, so it doesn't allow us to use any sort of glue. Like we even tried Gorilla Glue. I know that's like a common thing in many households, and that just did not work at all.
Yeah.
However, once we like however, if you try to sand it down, you might have better results.
Yeah. Also, like a common thing that was happening, I would say issue that was happening at the end of our project was after the motor was pressing down, after it finished filling to the rim exactly, it would have this weird thing where it would keep on moving up and down. It wouldn't push fully, but it was just very awkward. So if you guys, we'll share our code in the description. So if you guys have any way to solve that, please let us know.
Yeah. Also, one more problem with the positioning of the motor was that whenever it pushed down on the water, it had the tendency to push the motor itself back up, and this was causing like failure with the tape itself.
Yeah.
However, it's still somehow is staying together. So
yeah, I mean, it's working for now. But like we said in the last video, and like Umesh said, the motor right now, based on our code, it goes up and down in intervals. And the reason that we coded it to be that way is because if the motor and lever just pushes the tap down indefinitely, the water will start to I guess the tank doesn't have enough air in it for the water to keep pouring out consistently, and it'll start to slow down and then just completely stop. So you have to let go of it and let it like fill the air for it to start pouring water again, which is why it goes up and down.
Also, that up and down motion that we had was also caused another problem with like our sensors, where our sensors were measuring the distance between the cups, and because it kept on checking in intervals, sometimes it would measure the distance incorrectly, leading to the water even filling after the program is supposed to be done. So make sure to kill the program once it reaches that 2 centimeter mark, because sometimes the ultrasonic sensor will measure above the 2 centimeters.
It varies a lot. The ultrasonic sensor, it's not like it's in one position and it'll just show the exact same number all the time when you log it. You'll see that it goes up by a little bit, down by a little bit.
1.77 to 2.3.
It'll go like up and down. So that kind of variation is something that you have to look out for.
Yeah, so if you could, just make sure to kill the program. Just have something exiting the loop.
Yeah, right when it hits that value that you want, it will hit it, because even though it's varying a lot, it'll pass that point. At least if you have a small range, it'll pass something within that range, and you can just stop it at that point.
Yeah. So like in your code, just make sure you put like less than 2 centimeters. So
it shouldn't be an exact value, because what if it skips from 1.99 to 2.1?
Yeah, exactly.
Then it's kind of it'll keep going. But if you have like a range between like maybe 1.8 to 2.2, then
something like that, it would be better.
So these are basically all of the problems that we faced in this project,
and we attempted to solve them. If you guys have any better solutions to solve
or your problems, we'll make sure to fix them ourselves.
Yeah,
or get back to you.
And let us know in the comments if you guys faced these same problems and how you went about fixing them.
Yeah. Okay. Take care.
All right. See ya.